Hey everyone, Advent of Code day 3 here today. Starting a little less early because a little bit of a rush to get to the computer, but it's all good now. I still have a little bit of time. Yesterday's problem actually was quite interesting to optimize. I think I had it in the description, but if not, I'll add the GitHub solution I have in there. There's actually a lot of very interesting ways to reduce big O. One being like using arithmetic sequences to sum the invalid IDs rather than manually looping to check them. Another being like pre-computing what you need and using like divisibility by certain particular divisors rather than string manipulation, which tends to be slower. Of course, on the other end, in terms of like rather than runtime size, if you cared about code size, there's some incredibly succinct regex-based solutions. Cool. We'll see how day 3 looks. Alright, let's get the input. That is a chunky input. Looks like a grid type problem. Range into banks. Each line of digits is a single bank. Within each bank, you need to turn on 2. And it forms the exact number you need to turn on. You need to find the largest possible joltage each bank can produce. Okay, so always 2 numbers. Cool. Great, so let's just have a helper method which will return an int. And how should we treat the numbers? Let's treat them as a list. So what we can do is list integer temp equals new array list, and then for string s in line, we just want to add that to temp. Parse into s. Cool. And then we can just do answer plus equals helper temp. Alright, now how do we actually do this? Well, obviously we'd rather have just the biggest number at the beginning, right? I think that's the key. So we want to find the largest number, so int largest equals 0. Now for int num in nums, if num greater than largest. Oh, we should also store their indices, max indices. Cool. So if the number is greater than largest, then we want to reset max indices, and then we want to do, we want to add it. We want to add the index. Oop, we can't do num then. We got to do the other for loop. Then we add it. Actually, we just add the index. Else, if it's instead equal to, we just want to add it, and we don't want to do anything. We also obviously do want to set largest equal to nums.getI. Cool. So now we have a list of indices. So if there's multiple largest numbers, so we do have to do -1. Okay. So if there's multiple largest numbers, So yeah, if there's multiple largest numbers, we just return the largest number times 11. Right, because if it's like 9, then we return 99. Otherwise, that means there's a single distinct largest number, in which case we want to take all numbers after it and find the largest in that range. So int largest remaining equals 0, and then for int I equals max indices dot get 0 plus 1, because we don't want to consider the number itself. If nums dot get I greater than largest remaining equals nums dot get I. Okay, so now we have the largest remaining number. We just want to return largest times 10 plus largest remaining. Let's see how that does. Ooh, it is not right. All right, well, let's do the example then. See how it goes. I guess we might as well also just print the answer, huh? Good. 89, yep. 78, yep. And 92. Interesting. So there's no cases where this is incorrect for the small numbers. Cool. Then let's instead... Actually, let's do this. I want to preserve the original line, so I'm going to do it this way. Now we can do a line plus... Put a space in, otherwise it's pretty unreadable. Cool. And now let's just kind of spot check. I see a 9, I see another 9, 99 makes a lot of sense. I see a 9, I see a 9, I see an 8, 98 seems like the largest, 77 makes sense, 82, I see 82 here, I don't see another 8, so that one makes sense as well. Huh. Yeah, no obviously wrong cases. I see 99, yep. 80, 86, yep. I mean, at a glance, all these numbers look reasonable, so it's interesting that my total answer is wrong. Let's see what cases I might be missing. Alright, let's try some examples I can think of. So like 111, 1112, 1122. What would each of these give? Aha, this gives the wrong value. Right. Why is that? Because the largest would be just any of these ones, right? Oh. Right, so if nums.get last greater than largest, then we return largest times 10 plus nums.get last. Okay. This has changed my answer by much. It adds exactly 1 to the answer. Oh, I've mispressed the button. Dang, I was 1 off. So sad. You need static friction. Oh, it's 12 batteries now. Okay. Well, that's a bit tough. So I mean, the first part is still kind of similar, right? We find the largest value. Actually, wait, isn't this basically just find the largest value that's not within the last 11? And then once you find it, find the largest value not within the last 10. Okay, let's see if I can write up something that does that. So private int, I guess bounded max index list integer nums bound. So basically all we want to do here is take the largest int for before we reach said bound. Something like that. Ignore all the other stuff and just return largest. Oh, actually, let's do this. Bound 1 int bound 2. Bound 2 is basically how many numbers to exclude from the end, and bound 1 will be how many numbers to include at the beginning. Actually, also, let's just return the index instead. Int index equals 0. Index equals I. Because once we know the index, we can also just get the actual number, right? Like, I think that's quite trivial. Okay, so now rather than doing this, what we can do is basically, well, we know we need 12 numbers, right? So this is the best way to do that. Maybe a string. Yeah, I'm kind of down for a string. So what we can do is for int I equals 0, I less than 12. Oh, actually, other way around, right? 12 greater than 0, I minus minus. We want to basically int index equals bounded max index. Oh, cur index equals 0. Oh, oops, nums cur index and then I. So once we get that, we set cur index. Actually, we can just set cur index equal to this. Alright, and then s plus equals nums.get cur index. So I guess let's run. Nope. Oh, the numbers are too big. Long.parse long. You know, it's always a lesson to learn. Never trust ints. Okay, this one, the index is not going to be outside of it. 999, yeah. 899, I mean, all these numbers look somewhat reasonable. We'll see if it's correct. Nope. Alright. Let's take this and see how close we get. So we have 9, wait. The problem is that this needs to increment by 1. Okay, we have 9, 8, 7, 6, 4, 3, 2, 1, 1, 1, 1. Yep, and then we have 8, blah, 1, 9, 2, 3, 4. Oh, interesting. So this is saying, oh, oops, I'm reading the wrong thing. Okay. 4 3 4 2 3 4 4 3 4, and then it ends with 7 8. Yep. And then the 8 8 8 9 and a bunch of ones. Ooh, okay, this looks better for sure. Let's see what answer it gives. Nice. Okay. Yeah, so in hindsight, really could just generalize this a lot, huh? Let's see, would 2 have worked here? Like, does this just straight up work? It does straight up work for part 1 as well. Okay. Makes sense. Because in each case, obviously every number is dominated by the very first value. So you want to maximize at all costs. But obviously you can't maximize to the point where you don't have numbers left, which is why you only look in the first few numbers. Cool. Not a very fast day. I mean, 500 people already beat me. Definitely could have been better, but it was an interesting problem for sure. I will see you tomorrow.